Lesson 6-4, Elimination. Our essential question is, how do you use the elimination method when you are not given opposites? Our first example says, use elimination to solve the system. 6x minus 2y equals 10, and 3x minus 7y equals negative 19. And the question is, how could we create opposites in this system? That's the question that we need to think about first. Well, to create opposites, we are going to use multiplication because we can multiply anything that we want times an entire equation. As long as we multiply the same thing on both sides, we're not changing the value of that equation. We're just creating an equivalent equation. So we're going to use multiplication to create opposites here. So it's kind of like when you work with common denominators. If I look at the coefficients in front of x, I see 6 and 3. In front of y, I see negative 2 and negative 7. If we were going to work with fractions with those denominators, I would prefer, because it's your choice which one you want to work with, I'd prefer to work with the 6 and the 3. Because I know that the opposite of 6 is negative 6. So over here, I'm just going to write that to remind you. So opposites would be 6 and negative 6. So my goal would be to eliminate the x's in this system. So to do that, I need to turn this equation on the bottom, turn the coefficient 3 into a negative 6. I know that 3 times 2 is 6. So if I multiply by negative 2, I believe I will have the opposites that I'm looking for. So that bottom equation, the new equation, will be negative 6x and then positive 14y and positive 38. The top equation is not changing, so I leave that one alone. And now I have opposites. I can eliminate my x's and add together my system. Remember, the reason that this is okay is because we're multiplying both sides of the equation by negative 2. So whatever I do to one side, I have to do to the other side to preserve that equality. Now I add together my system and I get 12y equals 48. 48 divided by 12 gives me a nice number, y equals 4. So 4 is the y coordinate to my answer. I take that 4 back to the top. Either one of the equations is okay to work with. So I've got 6x minus 2 times y, which is 4, equals 10. 2 times 4 is 8. And I continue solving. 10 plus 8 is 18. 18 divided by 6 is 3. So x equals 3. So my solution is 3, 4. So I created opposites by multiplying one equation by negative 2. And then I added together my system. Remember, one of your variables has to cancel out. That's the whole point of elimination. If it doesn't cancel out, you've made a mistake. Example number 2. We have a couple of different options that will work on this one. Check out the coefficients. We have 9x and 3x. I could turn the 3 into a 9. Or I've got a plain y and a 2y, a positive 2y. So I am going to change that plain y to the opposite of 2y, which is negative 2y. So the top equation on this one becomes negative 18x minus 2y equals negative 26. The bottom equation does not change. And I can add together my system. The y's are eliminated. I get negative 15x equals negative 30. Dividing by negative 15 gives me x equals 2. I can bring that 2 back to either one of my equations. Make sure that you plug it in for x, because it was the x coordinate that was 2. So 9 times 2 plus y equals 13. 18 plus y equals 13 then. If I subtract 18, 13 minus 18 is negative 5. So y equals negative 5. Okay, my third example here. 4x and 3x. 2y and 3y. These coefficients do not have anything in common. So I'm going to need to change both of them to get my opposites. It doesn't matter which one you change, whether you eliminate the x's or the y's. I'm going to eliminate the x's. So coefficients of 4 and 3. 4 and 3 are both factors of the number 12. So I am going to multiply by 3 on the top equation to give me 12x, and then negative 4 on the bottom one to give me negative 12x. This method will always work. If you're not very good at figuring out like common denominators, like I did on the last two to figure out what to multiply by, this method will always work. If you take the two coefficients and flip them around and make one of them the opposite sign that it was originally, it will always work to give you opposites. So my new system is 12x plus 6y equals 24, and negative 12x minus 12y equals negative 36. Okay, the x's have eliminated themselves. 6 plus negative 12 is negative 6. 24 plus negative 36 is negative 12. So I can divide by negative 6 on both sides, and y equals 2. Go back to either one of these originals. 4x plus 2 times 2 equals 8. I always use one of the original ones, not the new ones, because they have bigger numbers. So 4x plus 4 equals 8. Subtract 4. 4x equals 4. And divide by 4. X equals 1. So 1, 2 is the solution to our system. One more like that. On this one, I'm going to eliminate the y's because the numbers are smaller. So flip the 3 and the 2, make one of them negative, and our system will eliminate. 18x plus 6y equals 6. Negative 8x minus 6y equals negative 16. The y's have eliminated. 18x plus negative 8x is 10x, and it equals negative 10. If I divide by 10 on both sides, x equals negative 1. So my x coordinate is negative 1. Go back up to the top with that negative 1. 6 times negative 1 plus 2y equals 2. Negative 6 plus 2y equals 2. Add that 6 to cancel it out. 2y equals 8 divided by 2. Y equals 4. So negative 1, 4 is our solution. You should be able to write a summary now, answering the essential question. Make sure that you use complete sentences.